So we will first see the resistors of 8051. Now, what is the function of resistor? To hold the value temporarily here. Now, it's usually, there is a difference between the RAM and a ROM. RAM is a random access memory, stores data temporarily. And ROM is read-only memory, is used for storing a program. Usually when you write a program, it goes into a ROM and microcontroller goes on reading that program and goes on executing that program. But RAM जो होता है 8051 में, that RAM consists of resistors, okay? And those resistors are used temporarily while during the execution. Now see, adding that earlier example you take, you need to add 3 numbers. 21 was stored in the accumulator, then 42 was to be added in 21, and then after that 12 was supposed to be added in the addition what you have earlier. So these numbers which are to be added, when they come from ROM, have to be stored temporarily somewhere. Like if I give you example, if I tell you to add 21 and 42, what will you do? You will remember the value 21, you will remember the value 42 in your brain. You not realizing, but you are storing it somewhere in your brain. You are using resistors temporarily, and then you do addition, 21 plus 42. And answer also you store it in the brain. So answer all goes into accumulator again. But for doing this addition, you need temporary resistors, right? So yesterday we have seen that input to the ALU is through 2 temporary resistors, temp1 and temp2. Apart from those resistors, there are certain resistors which are used extensively. And these are the resistors which are used extensively. The first is A. A stands for accumulator. A stands for accumulator. So as you know, accumulator, to accumulate, to go on adding. So whatever is the addition, that goes back to the accumulator. Now 2 numbers have to be added, for example. First number is stored in the accumulator, that was 21, and the second number, which was, because now once it is in the accumulator, you cannot put another number unless you add. So the second number needs to be stored in a temporary resistor, and when the addition is done, the answer goes back again to the accumulator. Suppose if you want to add 10 numbers, then each time the answer will be, first addition if you do, answer will be in the accumulator. Then the next number is taken, answer, again the calculation is done, answer will be in the accumulator. So that is why it is called as accumulator. Jama kara jado. Accumulate means jama karna. Understood? So the accumulator is one such register, and obviously it is a 8-bit register. Most of the resistors in 8051 are 8-bit resistors. Now, usually when it comes to holding the address, the resistor needs to be 16-bit. But as you know, 8-bit data bus jo hai, that data bus itself is a 8-bit. So even if I am saying that some of the registers are 16-bit, but those registers also are divided into 2 parts, lower byte and higher byte. Okay, so for example, program counter. I mentioned about the program counter in earlier lecture. Program counter. What is the role of the program counter? By now you have understood. What is the role of the program counter? To keep track of the program. What do you mean by keeping track of the program? It tells CPU from where the next instruction or data, whatever it is there in the store in the program, needs to be fetched. Always you remember the function of the program counter. So program counter keeps telling CPU the next address from where it has to bring the things. Address is always 16-bit. And we have seen multiple times why address is 16-bit. I need not repeat it again. Address is 16-bit. So to hold a 16-bit address, I require a register which is of 16-bit. Obviously, है ना? So that register is 16-bit register, but obviously, physically, there are 2 bytes assigned for that. Okay, एक साथ नहीं रहेगा, क्योंकि access करने के लिए उसको 2 bytes लगते हैं. Similarly, there is one register called a DPTR. DPTR, data pointer. Okay, data pointer. Now this pointer, counter, also they are similar in nature, like they point to some memory location. Exact use, you will understand DPTR का exact use क्या है when we are going to see instructions related to DPTR. Data pointer, it's going to point some data. Where the data is stored? In the memory. Right? Data is always, anything is stored in the memory. What is the address of the memory? What is the length of the address? 16-bit. So DPTR also is 16-bit. The only thing is that it is divided into, again I told you, that is also divided into 2 parts, DPH and DPL. DPH and DPL. L stands for low byte, H stands for higher byte. So since data lines are 8-bit, all the register lines are also 8-bit. So anything that is required 16-bit thing, it has to be divided into 2, higher byte and low byte. Apart from these registers, that is accumulator, program counter, DPTR, data pointer, you have other registers such as B register. Like you have accumulator, you have B register, but B register को हम लोग कोई full form नहीं है. A for accumulator, B for, there is no full form as such for B register. But B register is going to be used whenever there is a multiplication and division, mathematics operations, arithmetic operations. Okay, whenever you are going to study, I propose in the practical you might have done this multiplication of 2 numbers. Have you done this practical? If not, you can do it on your Kyle. If you have Kyle, maybe you can write that program of multiplication and division and can understand how exactly A accumulator and register B are used. Okay? So don't ask me what is the full form of B. There is no full form for B. It is, since we are calling accumulator as A, there is one more register called B used in multiplication and division operations. Okay? Apart from that, you have important registers, temporary registers, like R0 to R7, general purpose register. R0 to R7. These are called as general purpose registers. I hope you know the meaning. What is general purpose? No specific purpose. So how many are general purpose registers? R0, R1, R2, R3, R4, R5, R6, R7. How many are there? 8. I hope you are able to count properly. So 8 general purpose registers. But remember, though I have shown only 8 general purpose registers here, but in reality, there are 4 such banks inside 8051. 4 such sets inside 8051. Matlab, same name se. R0 to R7, R0 to R7, R0 to R7, R0 to R7. I'm talking about now RAM. Okay, I'm not talking about ROM. So in 8051, I showed you the comparison earlier, previous lecture. 8051, then 31 and 52. So in 8051, what was the size of the RAM? 128 bytes was the size of the RAM, right? In 52 it becomes 256 bytes. So I'm talking about that 128 bytes. Bytes is 8 bits. So 8 bits, 8 bits, 8 bits, 8 bits, 8 bits. Likewise, I'm going on till 128 bytes. If I have to convert those 128 bytes into bits, I will have to multiply it by 8. For converting bytes into bits, I will have to multiply it by 8 because 8 bits is equal to 1 byte. So what is the size of the RAM? 128 bytes. If I ask you size of the RAM in terms of bits, multiply 128 by 8 and tell me the answer later. ठीक है, तो वो RAM की मैं बात कर रहा हूं. वो RAM में ये सारे रेजिस्टर्स RAM में आते हैं. Accumulator is a part of RAM. And what makes me to say this? कोई analogy आप एग्जाम्पल दे सकते हो मुझे? मैं क्यों बोल रहा हूं accumulator is a RAM? RAM is random access memory. You can read as well as you can write. तो RAM accumulator में मैंने बोला आपको कि answer gets again stored in the accumulator, है ना? Storing again in the accumulator मतलब क्या है? Writing. Whenever microcontroller stores anything in the memory, it is nothing but writing. And when microcontrollers takes anything from the memory, it is reading. Make it very clear. ठीक है. So these resistors R0 to R7, मतलब 8 resistors, 8 byte, a part of a RAM. And what I told you that this is one bank, register bank 0, register bank 0. Likewise, you have 3 more. Register bank 1, register bank 2, register bank 3. Each having 8 resistors. Each with the same name of resistors. R0 to R7. So how many bytes are consumed out of 128? How many bytes are consumed by the general purpose resistors? 32. 8 into 4, 32. So 32 bytes of RAM are consumed by these general purpose resistors alone. At any given time, you will be able to use either this bank, this bank, this bank, or this bank. Did you get it? ऐसे नहीं कि चारों के चारों बैंक आपको अवेलेबल दे रहे थे, नहीं. प्रोग्राम लिखते समय आपको कौन सा बैंक यूज करना है वो सिलेक्ट करते हो. ऐसे क्यों आप धीरे धीरे सीख जाओगे. आई डोंट वांट यू टू get confused right away, and even if I tell you right now why it is so, you will not understand unless you write some code in which separate banks have to be used. Remember for time being that at any point you will be able to use only one bank. So these are the registers which are used extensively in 8051. I mean, second summarize: A, accumulator; B, register, multiplication, division; then there is a program counter; then there is a DPTR divided into 2, DPH and DPL; and then there is a bank of registers.